South Africa, a land blessed with a rich abundance of mineral resources. Where South Africa has developed the technologies to process these minerals into their purest forms, surrounding industries have developed, thrived, and become world leaders. As the world's demands evolve and become more advanced, so the demand for next-generation technologies and materials are becoming more essential. Aviation, medical, and military equipment needs to be lighter, tougher, and more corrosion-resistant. Electronics need to be faster and more efficient, and technologies such as solar photovoltaic are necessary to alleviate our demands on fossil fuels. Our nuclear power demands are increasing, and the materials required to complement this technology are essential. Marine, offshore oil and gas exploration installations and other extreme condition equipment need to be extremely corrosion resistant. Our processes need to be faster and cooler. Titanium, silicon, hafnium and zirconium are these materials, each with amazing technological properties and a diverse range of applications. South Africa has the second biggest available deposits of these materials in the world. Unfortunately, there are currently only 3 countries in the world that own the technology to refine these mineral ores into their pure metallic form. This makes it exceptionally difficult to develop downstream beneficiation industries due to cost and availability. Until now. Rare Metal Industries, in partnership with the National Empowerment Fund, the IDC, and Magnesium and Metals Limited, has acquired the technologies to develop the world's first integrated specialty metal complex, a processing and refining center for minerals which up to now South Africa has exported in their raw form. Welcome to the world's first integrated specialty metals complex. Titania slag and zirconium silicate, both products of existing mining and smelting operations on the Cape West Coast, are currently exported to countries with titanium and zirconium production technologies. By locating the new complex in this area and utilizing a small percentage of the currently exported material to produce pure metals, this would result in an increase in value of over 10-fold. The complex has been strategically designed to facilitate multiple rare metal production processes, titanium being the largest component. Titanium charge preparation is the starting phase of the titanium production process. Titania slag is prepared and mixed with exact amount of high-grade carbon into batch hoppers. Carbon is used as the reductant in the chlorination process. The batches of titania slag and carbon are fed into specialized chlorination furnaces. At a temperature of 750 degrees Celsius, chlorine gas is introduced into the furnace. This reacts with the titanium to produce titanium tetrachloride gas. This titanium tetrachloride gas is then purified through a distillation process and condensed into titanium tetrachloride liquid. Magnesium metal is the primary reductant in the Kroll process, in which the magnesium reduces the titanium tetrachloride to pure titanium. In the Kroll process, magnesium chloride is produced as a byproduct. This magnesium chloride is sent to the electrolysis plant and recovered into magnesium and chlorine in their pure forms by means of an electrolysis process. Magnesium is reintroduced into the Kroll process, and chlorine is reintroduced into the titanium tetrachloride process, creating a closed-loop reagent system. Liquid titanium tetrachloride is reacted with magnesium to free the titanium from its chlorine bonds. The result is a pure titanium metal and magnesium chloride. This reaction takes place in a chlorination furnace at about 750 degrees Celsius in a bed of molten sodium chloride. The titanium and magnesium chloride mixture is then separated in a series of column reactors under extreme vacuum conditions. Due to the bubbling effect of gases being drawn from the titanium, The resultant pure titanium leaving the reactors is full of holes and is referred to as titanium sponge. Titanium sponge is crushed into small briquette-sized pieces, carefully weighed into batches of 300 kilograms, and then forged into billets in a 7,500-ton hydraulic press. These billets are melted into high-purity titanium metal ingots. This process takes place at nearly 2,000 degrees Celsius in a series of vacuum arc remelt furnaces. These furnaces rank among the most complex furnaces ever designed. Silicon tetrachloride production is also very similar to that of titanium tetrachloride. The difference being that hydrogen and chlorine gas are synthesized and reacted with the silicon tetrachloride to form trichlorosilane at 750 degrees Celsius. The trichlorosilane is crystallized into solar-grade silicone in the rectification stage at about 1100 degrees Celsius. The zirconium purification process utilizes many similar processes to the titanium purification process, the equipment being virtually identical. From this project, South Africa will create much-needed jobs, 2,500 directly and up to 6,000 indirectly. Increase forex earnings tenfold from processing material worth $200 million to over $2 billion annually in value. Receive over $1.5 billion in foreign direct investment. And above all, South Africans, including previously disadvantaged people, will participate in the project. This will be the world's first integrated specialty metals complex. There is no other like it on Earth.